Hello everyone, I am Manoj Darshan R and my registration number is 19MS1198. I am from VIT Chennai. Today I am going to explain about Elgamal digital signature. Moving to the topic, Elgamal digital signature is a digital signature scheme which is based on the difficulty of computing discrete logarithms. It was described by Taher Elgamal in the year 1984. The Elgamal signature scheme allows that a verifier can confirm the authenticity of a message M sent by the signer sent to him over an insecure channel. It is based on the algebraic properties of modular exponentiation. The algorithm uses a key pairs consisting of a public key and a private key. We use public key for encryption and private key for decryption. Now, moving on to now I'm going to explain about the working of this digital signature scheme. First, we need to select a prime number q, and we should also select a primitive root alpha of q. Next, we need to generate a random integer xa such that xa is greater than 1 and less than q minus 1. Next step is we need to compute y of ya. To compute YA, we have the formula YA is equal to alpha power XA mod Q. Next, we must generate keys for the user A. User A's private key is XA and user A's public key is Q comma alpha comma YA. Next, we need to generate a hash code M for the plain text capital M. M is equal to H of capital M such that M is greater than or equal to 0 and less than or equal to Q minus 1. In the next step, we need to also generate a random integer K such that K is greater than or equal to 1 and less than or equal to Q minus 1, and GCD of K comma Q minus 1 must be equal to 1. Now, in the further process, we need to calculate S1 and S2. We have the formula S1 is equal to alpha power K mod Q, and to find S2, we have the formula K inverse M minus XA S1 mod Q minus 1. Now we got a signature pair S1 and S2. Now, till now, we were calculating in the user A's side. Now, at user B's side, user B can verify and calculate. We can verify the message by calculating V1 and V2. To calculate V1 and V2, we have the formula V1 is equal to alpha power M mod Q. And to calculate V2, we have the formula YA power S1 into S1 power S2 mod Q. If V1 and V2 were equal, signature is considered valid. If V1 and V2 is not equal, then signature is considered as invalid. Now, let me explain you briefly with an example. Let's assume that Q is equal to 19 and alpha is equal to 10. Then now we need to generate a random integer XA such that XA is greater than 1 and less than Q minus 1. We say Q is equal to 9, we have Q is equal to 19. So Q minus 1 is equal to 18. And let's assume that XA is equal to Q because XA is less than 18 and greater than 1. In the next step, we need to find Y of A. We have formula YA is equal to alpha power XA mod Q. Now we substitute the values of alpha and XA and in this formula. We have substitute alpha as 10 and XA as 16 and Q as 19. 10 power 16 mod 19, we get YA is equal to 4. In the next step, let's generate keys for user A. We know that private keys is equal to XA and we have XA value is equal to 16. And public key, we know the values cube and alpha YA. So we are placing the same values here. Q, as we know that Q is 19, alpha is 10, and YA we just calculated in the previous step. That is 4. Now with these values, we generate an hash code M. M is equal to H of capital M, and M is such that M is greater than or equal to 0 and less than or equal to Q minus 1. Since we consider M is equal to 14 because 14 is less than greater than 0 and less than 18. In the next process, we generate a variable K. K must be greater than or equal to 0 and less than or equal to Q minus 1. And GCD of K comma Q minus 1 must be equal to 1. While finding the GCD of K comma 18, 18 is must be equal to 1, then K must be 5, because while finding GCD, how we are going to calculate K is by finding GCD. To find GCD, we must it must be like K into any number divided by 18. We get 5. Next, calculate S1 is equal to alpha power K mod Q. We know that alpha is 10 and K is equal to 5 mod 19. 10 power 5 is 10, 1 followed by 5 zeros, that is 1 lakh mod 19. We get 1 lakh mod 19 is equal to S1 is equal to 3. In the next step, we calculate S2. S2 is equal to K inverse M minus XA S1 mod Q minus 1. To find K inverse mod Q minus 1. We don't know the value K inverse, so we need to calculate K inverse now before finding S2. K inverse mod Q minus 1. That is 5 into some number, that it might be any number. When we do multiply it with 5, and the whole number, the number which is multiplied with 5 gives another number. That number must be divided by 18 to produce, which must have the remainder 1. If you multiply 5 with 11, it produces 55. If we divide 55 by 18, we get the remainder 1. So the K inverse 5 into 11 is equal to 1 mod 18. So K inverse is equal to 11. Now we got the value of K inverse, that is 11. We can now directly calculate S2. That is S2 is equal to K inverse M minus XA S1 mod Q minus 1. We assign the value 11 to K inverse, M 14 to the value M, and 16 and 3 to the 16 and 3 to XA and S1, such that we get 11 into 14 minus 16 into 3 in the brackets mod 18. By calculating all these values, we get minus 374 mod 18. Ultimately, we get the answer, that is S2 is equal to 4. That is, now we are getting S1 comma S2 is equal to 3 comma 4. Till now we calculate at user A's side. Now we are going to verify in user B's side. At B's end, V1 is equal, we can verify it by using this formula V1 and V2. By calculating V1 and V2. V1 formula is V1 is equal to alpha power M mod Q. That is 10 power 14 mod 19. 10 power 14, we split it into 10 power 5 into 10 power 5 into 10 power 4 into mod 19. 10 power 5, we get 3. 10 power 5 mod 19 is 3. 10 power 5 mod 9 is 3. And 10 power 4 mod 19 is 6. When we multiply all this 3 into 3 into 6, we get 54. Well, applying mod 19 to 54, we get V1 is equal to 16. Next, moving on to V2. V2 is, we have the formula, V2 is equal to YA power S1 into S1 power S2 mod Q. YA power S1 is 4 cube, 4 power 3, and S1 power S2 is 3 power 4. into mod q is mod 90. 4 cube is 64 into 3 power 4 is 81. 64 into 81 is 5184 mod 19. While after applying mod 19 to 5184, we get V2 is equal to 16. Now we got V1 and V2 value. Since V1 is equal to V2, we consider that signature is valid. Let me explain you with another example. In that examples, we got that V1 is equal to V2, that is signature was valid. In this example, let us see that what happens in the next. In this example, we are taking all the values that are different. Let's assume that q is equal to 17 and alpha is equal to 3. Now let's generate a random integer xa such that xa is greater than or equal to 1 and q less than q minus 1. We reach the conclusion that xa is equal to 15. Okay, since 15 is greater than 1 and less than 16, let's assume as xa is equal to 15. Let's compute ya. Ya we have the formula alpha power xa mod q. Ya is equal to 3 power 15. 3 power 15 mod 17, and we get value ya is equal to 6. Let's follow all the steps again once again. Let's generate a key for the user here. We get private key as xa, that is 15, and public key is q comma alpha comma ya. We know q is equal to 17, alpha is equal to 3, and ya is equal to 6. Let's place the value here. Now let's generate a hash code for the message m, for the message m, for the plain text m, capital letters. M is equal to h of capital M, that is m greater than or equal to 0 and less than or equal to q minus 1. We get value 12. Since 12 is greater than 0 and less than 16, we assume it as we assume the hash code as 12. Now let's generate a k such that k is greater than or equal to 0 and less than or equal to q minus 1, and the GCD of k comma q minus 1 must be equal to 1. K comma q is 16 and is equal to 1. After applying GCD, we get k is equal to 3. Let's calculate S1 and S2 here. S1 formula, we know that alpha power k mod q, that is alpha is 3, k is equal to 5. We substitute here once again. We get S1 is equal to 5. Next, we are going to calculate S2. S2 is equal to k inverse mod into m minus xa S1 mod q minus 1. Here we don't know the value k inverse, so we need to first calculate k inverse. K inverse mod q minus 1. K inverse 3 inverse. We know that k is equal to 3. We apply substitute k value here. 3 inverse mod 16. To calculate a 3 inverse, we need to multiply, to calculate k inverse, we need to multiply 3, the value 3, with the number and divide it by 16 such that it produces as a number 1. If we multiply 3 into 11, we get 33. If we divide 33 by 16, we get a remainder 1. Since it is the required parameter is fulfilled, we assign k inverse is equal to 11. Yes, 2. Now we are going to directly calculate S2. S2 is equal to k inverse into m minus xa S1 mod q minus 1. We know we just found out the value k inverse, that is 11. We know the value of m, that is 12, minus xa we know 15, and S1 we assign we know it is 5. 5 into 15, 75. If we minus 75 from 12, we get minus 63. If we multiply minus 63 with 11, we get the value minus 693. If you apply mod 16 to minus 693, we get the value that S2 is equal to 11. At the B's end, we can verify its value by calculating V1 and V2. If to calculate V1, we know the formula that alpha power m mod q. Alpha is 3, m is 12, mod q, that is q is equal to 17. 3 power 12 mod 17 is, we know the value V1 is equal to 4. Now we are going to calculate ya power S1 into S1 comma power S2 mod q. We get the value V2. We know that ya is 6. and S1 is 5 into S1 is 5 and S2 is equal to 11. You multiply 6 power 5 into 5 power 11 into mod 17. We get the value V2 is equal to 9. Here, if you see, now unlike the previous problem, we get V1 is 4 and V2 is 9. We're getting two different answers. V1 is not equal to V2. Hence, therefore, we conclude that signature is invalid. Thank you.